Hello everyone, so this is part 2 of the quantitative electrolysis calculations. Would have already looked at calculating Q, which is quantity of electricity, which is equal to the current times the time in seconds. Now, for these type of questions, the main aim, because I would have told you earlier that when a particular amount of electrons go around the circuit, right, that particular amount of electrons is directly proportional to our mass that is deposited at the cathode or the anode, right? So for these type of questions, we're really trying to find out the theoretical mass produced at our anode or cathode, at our electrode, right? And in mole concept, how we usually calculate mass is mass equal what? Mass equal moles times what? Mass is equal to moles times molar mass, yes. Right, and we're working backwards, so we know what mass is equal to. Mass is equal to mole times mass. But oftentimes in the question, we don't know what the moles is, because the molar mass it's given, if it's copy, you get 64 gram per mole. But for moles, there's a particular way that we calculate moles in electrolysis. So in electrolysis, mole is equal to Q times A. I might see it being written a little different, right? So mole is equal to Q times A, where Q represents the quantity of electricity, A represents the amount of atoms, so A for atoms, so QA, right? Divided by the mole of electrons. See how the electrons come in now? The mole of electrons, the E with a negative up at the top is, or a tilde, that's electrons right there. So the mole of electrons that actually flow around your circuit times the value of Faraday's constant, which is F, right? Let me just insert that right here. Faraday's constant. And note that Faraday's constant, F, equals 96,500 coulombs. That is the value of Faraday's constant. You have this equation already? Take a picture of it. Take a picture of it. That is our equation right there. And we already know how to calculate Q. How do you calculate Q? Q is equal to I times T. Right. Alright, let me just scroll a little. Okay. And note that Faraday's constant, it's, as it says, it's a constant. It will always be that value. So it will always be 96,500 coulombs. And really and truly, he was just relating the value. I don't have the information here. Do I? No, I don't have Faraday. How do I not have Faraday's constant here? Yes, I do. How did I miss all of this? Right. Now, for Faraday's constant, here it is. So Faraday, he said, it is used to calculate the masses of substances and volumes of gases formed during electrolysis. That's what Faraday's constant is used to calculate, volumes of gases and masses, right? And we know that it is for sure 96,500 coulombs. Now note that 1 mole of electrons, and this is why we're actually going to multiply it, because 1 mole of electrons is equal to 96,500, where 1 mole is always Avogadro's number, which is 6.022 times 10 to the 23rd power. So 1 mole of electrons is equal to 96,500 coulombs. If we had 2 mole of electrons, how do we calculate 2 mole of electrons? It is simply gonna be 2 times 96,500 coulombs. Right, I did not get to write it there. If we had 3 mole of electrons, it's simply gonna be, and let me just write it out, it's gonna be 3 times Faraday's constant. Good, that's it. I don't know how I missed this before. Alright. Okay. And now we are going to look at our first question that deals with calculations in electrochemistry. Now this question says determine the mass of magnesium. So we're calculating the mass of magnesium produced at the cathode. When a current of 7.5 amperes flows through a molten magnesium chloride for 25 minutes and 44 seconds. So the first thing you do is that you highlight all the important information. Highlight what they want you to calculate. So in this case, it's the mass of the magnesium. Highlight the numbers that they give you. So we got 7.5 amperes, which is A. Right? We got the time as well, 25 minutes and 44 seconds. We also know that we're calculating the mass of magnesium, and it's the mass of magnesium in molten magnesium chloride. So magnesium chloride in this case is our electrolyte. It's in the molten form, so there is no water present. It's not aqueous, it's just molten, so it's just molten magnesium chloride. Now the first thing you do when you're doing these calculations, number one, is that you're going to calculate quantity of electricity. So quantity of electricity, what's the formula again?
Q equal I times I.
Times T.
Times T, yes.
And for I, the value for I that we got was 7.5 amperes times T. T has to be converted in seconds, so we got 25 minutes, right? 25 minutes in seconds is 25 times 60, and we also have an additional 44 seconds plus 44, and be careful when you're putting this into your calculator, right? Seconds. So let us work it out. I'm gonna grab my calculator. Alright, so it's 25 times 60. That gives us 1500 plus 44, which gives us 1544 seconds. Right, and when we do this, our answer, we're going to multiply that by 7.5, we get 11,580 coulombs. The unit that we're using for quantity of electricity is in coulombs. Right, take a picture of this. Alright, so what? Ready? Alright, now this next thing that we're going to do is that we're going to calculate, not even calculate, we need to write our half equation at the cathode. So step 2, write half equation at cathode. And if you recall, what is the charge of your cathode? Your cathode has what charge? Cathode is negative, and the cations that go to it, they will be positive, right? And since we're going to calculate the mass of magnesium, right, since it's in the molten form, it's going to be Mg2 plus. Molten liquid. Right? Molten is liquid right there. At the end of electrolysis, do you remember what happens to our ions? Our ions become, that N word, the ions become what? Not negative, ions become neutral. Alright, they take their elemental state, and in the elemental state, magnesium is a solid. So that's what we have so far. We start off with our ion. which is magnesium 2 plus ion, and we end up with our neutral magnesium. Something is missing from this equation. It's a half equation, so we're missing our electrons, right? How many electrons are involved here? Let me actually take out the plus, because I left the space for a reason. How many electrons are involved here?
2.
It's 2 electrons. It goes from a 2 plus charge to a 0, so it's 2 electrons. And is this charge increasing or decreasing?
Increasing.
Is it?
Decreasing.
It's decreasing.
Going to the right, decrease.
Going to the right, you increase. Going to the left, you decrease. So if you notice that your charge is decreasing, it goes from 2 plus to 0, you can visualize a number line, right? A number line like this. So we start off with 2 plus over here, 1 plus over here, 0, 1 minus, 2 minus. Our charge is decreasing, right? So whenever your charge decreases, you put it on the left. And I actually should have drawn this number line the other way. My bad. Let me do it again. So right there, 2 plus is here, 1 plus is here, 0, 1 minus, 2 minus. Whenever your charge decreases, you're going to the left and your amount of electrons will be on the left, right? Since we're going that way. Now, note that we need to ensure that this is balanced, and you oftentimes multiply your electrons or your charges, the difference in charge, and let me just write it here. To find out the total number of electrons is equal to, so total E is equal to difference in charge times the amount of atoms, and this is of course after you have done your balancing, right? So amount of atoms on one side of the equation. So in this case, the difference in charge, it is 2 plus minus 0, that's difference. Going back to math, whenever you hear the word difference, you're subtracting, times the amount of atoms on one side. So if we look at our left, right, this is balance, of course. It's 1 magnesium on the left, 1 on the right, right? So in this case, on the left, we have 1 magnesium atom. It's 1 times 2 plus minus 0 is what? 2. So therefore, the amount of electrons that it should remain as is 2e, right? So always do this before you come to the conclusion of the amount of electrons. So this half equation right here is correct. Now look at what I'm going to do for step 3. Step 3, we are going to be calculating the mole, right? We're going to be calculating the mole because we need to get to the mass. We're going to calculate the mole. And for the mole, the equation in electrolysis, mole equal Q times A over mole of electrons times Faraday's constant. Q, the value of Q that we got earlier was 11,580 coulombs times the amount of atoms. As you can see here, it's 1 atom present. And you can just look at one side just to not get confused. It's 1 atom present divided by, and notice I'm using my units. You're going to see how those cancel. Divided by the mole of electrons. If you look at your half equation, it's 2 electrons involved. So the mole of electrons is simply going to be 2e times Faraday's constant, which is what? 96,500 coulombs. And right here, I'm missing something important right here. Because it says mole of electrons, so it's going to be 2 mole E. Alright, so when we do our division, notice C is going to cancel C, right? And let us work that into our calculator. 11,580 divided by 2 times 96,500 is equal to 0.06 mole, because all we're left back with is mole right there as our unit, right? Then the last thing that we're going to do is we're going to calculate the mass. And for mass, we already said that mass, guys, bear with me, I don't have any more space. Mass equal mole times molar mass. Mass equal mole times molar mass. The mole that we got was 0.06 mole. The molar mass of magnesium, you can always look this up, it's 24 G slash mole, right? And 24 times 0.06 times 24, the answer that I get is 1.44 mole. Will cancel mole, grams. Now what this answer is telling us is that this is the mass that we expect to be produced at our electrode, right? I'm gonna do another question in another video, so just recap. When you need to calculate the mass in electrolysis, the first thing you calculate is the quantity of electricity. Then you write your half equation, then you calculate the mole, and then you calculate the mass. I will see you in the next video.